Hey y'all, it's your personal math teacher, Mr. Boyden. I'm back at it again, and today we're going to be looking at area, that's surface area, and volume of solids. Now, in this lesson, we have a whole bunch of formulas. In this case, we're talking about an IB class, so what I have on the screen right now is parts of the IB formula sheet. Okay, and so what we're going to be talking about mostly are right pyramids. We're going to talk about right cones. And all that means, a right cone means that, and a right pyramid, it means that if you draw a line down from the top down to the base, it's going to hit at a right angle. Okay, that's all that means. Okay, and then we're also going to have the curved surface of a cone. That's what we're talking about, surface area. And then we're also going to be talking about spheres, which if you don't know is basically a ball. And usually we draw them like this. Or like the Earth. We'll actually see a question in the video today about the Earth. Okay, so there is some prior knowledge that we're expected to have coming into this video, and so you may choose to pause the video here if you want to write these down. If you want them as we go through, you can always come back. I'll be coming back. Also, the prior knowledge that we're supposed to have coming into this are things that we would have learned like in a basic geometry class, like the area of a parallelogram, of a triangle, trapezoid, circle, the circumference of a circle, cylinder, prism. Okay, so those are things we're expected to know. In today's lesson, I'm not going to be doing a bunch of conceptual explanations because it would actually do multiple videos about the concepts of all of these formulas. Today's video is focused on how do I use them to answer questions. And so we're going to dive right in, and it's just going to be example, example, example the whole way through today. Okay, let's get started. Okay, first one. A metal sphere has a radius of 12.7. Find the volume of the sphere, expressing your answer in, basically that says in scientific notation. So the first thing that I'm going to do is I'm going to scroll back up for a moment, and I'm going to go find volume of a sphere, and it's right here, 4/3 pi r cubed. So I'm going to start there. So work for part A. We know that volume is 4/3 pi r cubed, and we were told the radius, which is really convenient. Let's plug that in. So 4/3 pi times 12.7 cubed, and then we're going to type that in a calculator. Ideally, your calculator has a pi button. If it doesn't, please use 3.14 as an approximation, and then if you're using 3.14, the numbers you get in your calculator, or if you're using your phone or whatever, they're going to be slightly different than mine. If they're just slightly different, and that's the reason why, that's totally fine. It's not a problem. So I'm going to take a moment to type this in. Okay, and I got 8,580 looks like 0.25. And let's pay attention to our units. Usually when we do area and volume, we really do need to pay close attention to our units. This was centimeters, and the volumes are a cubic metric, so that's going to be centimeters cubed. However, this right now is in standard form for a number. And they asked us to write it in scientific notation. That's what that right there is saying. Okay, so guys, if you don't remember, I'm going to do just a really quick little crash course right up here on scientific notation. Scientific notation, you've probably seen numbers like 2.5 times 10 to the 5th. Okay, and so a lot of teachers will teach this as a decimal slide of 5 places. It absolutely is, but my experience has been that if I teach it as a decimal slide, people will often slide it in the wrong direction. And so I want to coach you a little bit here to think about, if I multiply by 10 to the 5th, does the number get big or does the number get small? Like, does 2.5, does it get bigger or smaller when we multiply by 10 5 times? Well, obviously multiplying by 10 5 times will make the number big. And if you were about to slide the decimal to the left and make it a little decimal, this would be a way you can catch yourself, because that would tell us that we move it to the right 5 times. So 2.5 to the right once, twice, thrice, 4 times, 5 times, and you need to fill in zeros there. Okay, so this is a way of writing 250,000. Okay, let's do an example going in the other direction. Another way of doing this would be like if I had 0.0003874. Okay, so how would we do that? Well, what we're looking for, and y'all, it says it right here, I'm boxing it right now. It says that number in front needs to be a number between 1 and 10. So we need to think, where am I going to move this decimal point so that it creates a number that looks like it's between 1 and 10? And that spot is going to be down here. And how far off is that? That's 1, 2, 3, 4. So this is going to be 3.87 times 10 to the, well, it's going to be either 4 or negative 4. And this is where people get a little bit mixed up. Because I want you to think, let's say I put 4 down here. Some people say, oh, you slid it to the right, so that's going to be 4 as the exponent. But hold on a second. If I multiply 3.87 by 10 to the 4th, that's going to be a really big number. But notice, this was a really small decimal. It wasn't a big number. And so that's not right. Okay, so that's why I take notice that, like, wait a minute, I need this number to be small. And so that means I need a negative exponent so that it makes the number smaller, not bigger. Okay, so with that in mind, let's come back down here to the question we were just working on. Let's write it in scientific notation. So I need the decimal to actually be here. That's 1, 2, 3. So I can write this as 8.58. I'm going to round a little bit here, y'all. 8.58 times 10 to the, looks like we slid it 3 places. So 10 to the 3rd cubic centimeters. Let's go to part B. The sphere is to be melted down and remolded into the shape of a cone with a height of 14.8. Find the radius of the base of the cone, correct to 2 significant figures. Okay, so it's a good idea always to start out with a formula. So like we know that volume of a cone, and that was written up above, is 1/3 pi r squared times height. And so it's good to start with a formula, but then we also have to be problem solvers a little bit. So they didn't say it explicitly, but I think we would assume if you melt down metal from one shape into another, you still have the same amount of metal, the same volume of metal. And so we're going to use the answer we calculated in this first part, 8,580. I'm going to round it this time to the nearest whole. That would be the same volume. And so now we have 1/3 times pi times r squared times the height, which we know because they told us it's 14.8. And so y'all, for a lot of people, just realizing, hey, the volume stayed the same. That's possibly the hardest part, because now it's just algebra steps. And in fact, we're going to do all of the algebra moves in one go here. We're going to multiply both sides by 3 to get rid of the 1/3. We're going to divide by pi. And we're going to divide by 14.8 in the same move. And so what's going to be left over here is r squared, and then over here on the left, we need to type that in a calculator. Now, if you're typing this in with me at home, please make sure that you put this entire denominator in parentheses. Otherwise, there's a chance that your calculator is going to misinterpret what you mean, and we don't want that. So I'm going to type this in now. All right, and I got 553.6. But they asked for the radius, not the radius squared, so let's take a square root on both sides. And I'm getting a number now that rounds to 24. And the reason I'm doing that is they said do it to 2 significant figures. And I need units, 24 centimeters. Okay, and then always circle your answer at the end. All right, let's try another one. In this case, we're going to be looking at a cone. It looks like they maybe chopped the top off of that cone. Let's read and see. A solid right circular cone has a base radius of 21 and a slant height of 35. Notice that both of those are already labeled. A smaller right circular cone has a height of 12 centimeters and a slant height of 15 and is removed from the top of the larger cone as shown in the diagram. And then they have a few questions below here. And so they want us to calculate the radius of the base of the cone which has been removed. I'm going to mark that on the picture real quick just so I don't forget it. They want to know what that is. They want to know the curved surface area of the cone which has been removed, and they want to know the curved surface area of the remaining solid. All right, so guys, as always, I want to encourage you to pause the video anywhere in here that you want to. If you're taking notes, get your notes set up. If you want to try the question, make an attempt, that would be awesome, and then basically you'll just be listening to me walk you through it. That would be an awesome way to do this. In any event, I'm going, so here I go. Okay, so they want us to find the radius of the base of the cone. Well, let's take a look. The thing that jumps out at me about that is that this is a right triangle. They told us it's a right cone, and that's a right triangle, and I know 2 sides, and I'm missing one. So for part A, I can just use the Pythagorean Theorem. X squared plus 12 squared equals 15 squared, and so I get x squared equals plus 144 equals 225. When I subtract the 144, I can get x squared equals 81, and I can take a square root and find out that x is 9. Okay, and maybe I should rewrite that as that the radius is 9, just to be really clear to my grader that x is the radius. I probably should have labeled it as r to begin with, now that I think about it. All right, let's keep going. So what could we do next? They now want us to give the curved surface of the cone which has been removed. Okay, so that cone up top. Now, for a cone, surface area is the equation pi times radius times the slant height. Slant height is not the height. The height going up through that cone up there is 12. The slant height, the one going up the side, is 15. Okay, slant height, it's like the height. It goes bottom to top, but it's slanted. It's not going directly up at a right angle. So all we need to do here, though, is just plug in the numbers that we know. So the radius of that small cone, we just found out that that's 9. And then the slant height is 15. And so that comes out to be 135 pi. And what are the units? Centimeters. So this is an area, so it's going to be square centimeters. Okay, and that's all the next one is. If you want to type that in and get a decimal, you sure can. In a real world context, we would. In a math context, it's up to you if you want to do that. Okay, what's C? C is calculate the curved surface area of the cone. Oh, the curved surface area of the remaining solid. Okay, so what we might want to think about to do this one is we started out with a whole cone. If we knew the surface area of the whole cone minus the surface area of the small cone, what would be left over is the surface area that remains. Okay, that would be this thing down here. So let's do that calculation. Since these are surface areas, once again, it's going to be pi RL, that's radius, times slant height. So let's plug them in. So the surface area of the whole thing would be pi times radius. The radius of the whole is 21. The slant height is 35. Minus the surface area of the small one. And you know what, guys, we already did that, so we're not going to do the calculation again. We're just going to write minus 135 pi. Okay, let's grab our calculator. So 21 times 35, what's that? That's 735 pi. So we have 735 pi minus 135 pi, and that's pretty easy. Oops, I forgot the pi. That's pretty easy to do. That's just 600 pi square centimeters. Okay, so this is an example where a question, it can look really hard. It doesn't mean the calculations are going to be hard. If it feels hard, it just means we need to slow down a little bit and analyze the picture carefully so we can develop a good strategy. Okay, let's try another question. This one's going to be about the Earth. That's where I am today. Is that where you are today? Hopefully. All right. Assume the Earth is a sphere. Kind of close enough. With a radius of 6.38 times 10 to the third. And there's a few things they want from us. Calculate the surface area of the Earth in square kilometers. Write down your answer in scientific notation, and then find the percentage that's covered by water. All right, let's do this. The first thing that I want to do, because when I go to do A1, and they want the surface area of the Earth, and that is 4 pi r squared. I need the radius, and I'm noticing that this radius they gave me is going to be not as easy as it could be to type in a calculator. So I'm going to turn that into standard notation. So 6.38, make the number bigger by sliding 3 places. 1, 2, 3, that's 6,380. So when I go to plug this in, I'm going to plug in that number in standard form. So 4 times pi times 6,380 squared. Let's go to the calculator. Okay, and I'm getting a big number. I can see why Part B asks us to write this in scientific notation, because what I'm getting is 511,511,506,576 square kilometers. And that's perfectly good for A1, but A2 asks us to do this in scientific notation, so we should probably do that. So where does my decimal need to be? It needs to be right here, so it says 5.1. And so how far does it need to move? Well, it's right down here at the end. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to get, and we're going to do a little bit of rounding here. We're just going to keep 3 digits. 5.11 times 10 to the 8th square kilometers. Okay, now guys, you're like, wait, why do you get to round all that, man? Guys, that's the whole point of scientific notation. It's so that you can write really, really big or really, really small numbers with a smaller number of symbols. If you've taken chemistry in particular, you've seen this. In particular, if you work with something like Avogadro's number, it's not that fun to write the whole thing out, but if you can write it out in scientific notation with 3 significant figures, it's not too bad. Okay, so that's what that's for, and that's why we're going to do a little bit of rounding sometimes when we do scientific notation. Let's answer that third question now. That'd be part B. They asked us, the surface area of Earth that's covered by water is approximately 3.61 times 10 to the 8th kilometers squared. Calculate the percentage of the surface of Earth that's covered by water. Okay, so percentages are always how much out of the whole amount. Okay, and so it's going to be how much water, which is 3.61 times 10 to the 8th kilometers squared, or square kilometers, divided by the total amount, 5.11, we just calculated that, times 10 to the 8th square kilometers, except I should write it as to the 8th, not times 108, whoopsies, 10 to the 8th square kilometers. And let's look at how that simplifies. Now it might seem weird, but look over here on the right. This 10 to the 8th on top and the 10 to the 8th on bottom, they're both being multiplied and divided, so they actually fully cancel out, as do the units. And what we're left with is 3.61 over 5.11, calculator time. And what I get is 0.706. They asked for a percentage, and so that would be 70.6%. All right, new question. The following diagram shows a perfume bottle made up of a cylinder and a cone. The radius of both the cylinder and the base of the cone is 3. Okay, notice they have that on the picture for us. The height of the cylinder is 4.5. They've labeled that for us as well. And the slant height of the cone is 4 centimeters. Okay, let's see what we need to do here. They asked us to show that the vertical height of the cone is 2.65, correct to 3 significant figures. Show that the height is 2.65, correct to 3 significant figures. I want to suggest that you always draw the picture on these, or if you have the opportunity to print pictures when you're doing this, like if your teacher gives you an assignment, but if you have something you can draw on, my experience is it's a lot easier to do these questions if you can actually draw on them. So I'm going to draw this down the middle right here, because I said the height of the cone, and I'm going to connect this, and the reason that I like to draw is I've just noticed now that I just drew a right triangle. Okay, and what does that right triangle look like? Well, we were told that the radius is 3, and we knew the slant height was 4, and they asked us for the height. So now this is the second time in this video that an area and volume problem has gone back to the Pythagorean theorem. This is a totally common thing that happens. Now they asked us to show that it's 2.65. One thing I do want to say about when they say to show it, you do not get to start out the question thinking about it being 2.65. You have to start off from the given information and then show a logical process that leads to 2.65. So here's what we have to do. Let's Pythagorean theoremize this thing. So x squared plus 3 squared equals 4 squared, so that x squared plus 9 equals 16. Subtract the 9, and so we get x squared equals 7, and then let's take a square root of 7, and let's really hope that it's 2.65 when we round it. And mine goes 2.645, so that would round to 2.65. So this is what we're looking for. If we ask you to show something and we tell you what the answer is, we're telling you that to be nice, and probably because it's going to come up later in the question that you're going to need that value. So we're making sure that you have that value, but you still have to show the process which leads to it. All right, A2. Now they want us to calculate the volume of the perfume bottle. We have to be not careful, but we have to be precise when we do this, because it's two shapes added together. Because this is going to be the volume of a cone plus the volume of a cylinder. And so what we might want to do is start out with those two formulas. So 1/3 pi r squared times height plus pi r squared times height. There are different ways to simplify this, but let's plug in values and let's see what happens when we actually plug them in. So when I do this, I'm going to get for the cone, and make sure you notice, guys, these two radii are the same because they told us so, but the heights are not necessarily the same, because the one on the left is the height of the cone and the one on the right is the height of the cylinder. So when I go to plug this in, 1/3 pi times 3 squared times the height of the cone, which they got 2.65, and if they told us right here, they want it rounded that way when we use it. So let's use that. 2.65 plus pi times 3 squared times the height, this time of the cylinder, and the height of the cylinder is 4.5. All right, so at this point, we're going to go to the calculator, and let's type this stuff in. So that's going to take me just a minute. I'm assuming that's going to take you just a minute. Okay, and when I do that, I'm getting 152.2. 152.2. Let's check my units. It's a volume, and the input was centimeters, so that's cubic centimeters. Let's go to part B. They're telling us the bottle contains 125 cubic centimeters of perfume. The bottle is not full. Okay, that validates the answer I just got, because they said 125 is not full. I just calculated 152.2 would be what full looks like. So that makes me feel like my answer might be right. Okay, the bottle is not full, and all of the perfume is down in the cylinder part. We need to find the height of the perfume in the bottle. Okay, the thing to notice about here, guys, is they just told us cubic centimeters, cubed. What they're telling us, if it's cubic, is they just told us the volume, and they told us that it was all in the cylinder part, so they just told us the volume of a cylinder. Okay, and so if you're like, wait, what do you mean, man? Well, think about if this thing had a liquid in it, the shape that it would take, this lower shape, it would fill the shape of a cylinder. The height of it would just not be 4.5 because it's not going all the way up to the top. So when we go to solve this question, let's remember how to find the volume of a cylinder, pi r squared times height, and let's plug in what we know. They asked us for the height, so we don't know that. We do know from the image that the radius is 3, so pi times 3 squared times height, and we know the volume is 125 because they just told us so. And so now all we need to do is solve this thing. So let's divide both sides by 9 pi, and then we're going to know what h is. And so this question turns out to be fairly quick, actually. 125 divided by 9 pi. Make sure you put parentheses around your 9 pi, please, so your calculator understands you correctly. And what I just got is 4.42 centimeters. Okay, let's go consider what that would look like in the actual bottle and see if that makes sense. So they said 125 is the volume, and so it is full to 4.42, so it's almost full up to here, is what they're saying. Okay, I think that makes good sense. Let's keep going. What's next? All right, and I'm sorry because the font's going to get really small here, but I'll read it anyway. Temmie makes some crafts with perfume bottles like the one above once they are empty, and wants to know the surface area of one bottle. We are asked for the total surface area of the perfume bottle. The total. Now, I want you to notice here, in the way this question is written, I didn't write this one. They bolded the word total. Oops, sorry for jumping around like that. My computer will do that sometimes. They bolded the word total right here because a lot of people will forget to do everything. They're kind of giving you like, hey, just so you know, a lot of people make a mistake here, so be careful. Like, you know how to do it, but you might make a mistake. In order to find total surface area, let's go look at the picture again, and let's consider all the shapes that comprise the outside of the bottle. So what do we have? We have the cone on top, so we have the lateral face of the cone, which just means the side of the cone. We have a cylinder down here, we have the lateral part, and then the thing that I think a lot of people forget is that this circle down here is on the outside. So if we're going to do surface area, in fact, let me do this calculation up here. Let's do part C up here, total surface area. What I like to do on these is we are finding the area of a cone plus a cylinder, the face of a cylinder, plus a circle. Okay, and I always write it out in words first in my questionable handwriting, and that kind of just helps keep me grounded. Then I know what formulas I'm looking for. I don't get lost in the symbols, and I can just start writing those. So we learned earlier that the surface area of a cone is pi times r times slant height. For a cylinder, it's 2 pi r times h, and for a circle, it's pi r squared. And so we need to make sure we plug in the correct values here, but this is how we're going to get started. Now, this is where I've seen a lot of students get freaked, like, oh, that's such a big formula. Not really. I mean, it has a lot of symbols, but we're adding together a cone, a cylinder, and a circle. It's just addition. Okay, so don't get freaked out by that. Okay, let's start plugging in some values in here. So pi times the radius of the cone is 3. Oops, excuse me. No, that's right. Okay, I wanted to catch myself. I made a mistake. So 3. And then the slant height is 4. Plus 2 times pi times the radius, again, is 3. Times the height is 4.5. And then the circle, and that's pi times 3 squared. Now, when I simplify this, I'm going to first leave it in terms of pi. And so like at the beginning here, 3 times 4, that's 12 pi. This next one, I'm going to use a calculator. I'm just going to do 2 times 3 times 4.5. That's 27 pi. And then down at the end, 3 squared is 9. So we have 9 pi. And then I'm going to add those together. Okay, and 12 plus 27 plus 9, that's 48. So I'm going to write 48 pi, and then I'm also going to offer a decimal approximation of that in case someone's actually buying something to cover it with. So 150.8, and that would be centimeters, and this is an area, y'all, so that one's squared. Okay, so there's my work and answer to part C. And what was she doing with the bottles? Making crafts. Wants to know the surface area of a bottle. I'm assuming putting some, I don't know, glitter or paint or something on the outside. Okay, and then in part D, that is confirmed. The person, Temi, is going to cover the perfume bottle with a paint that costs 3 South African rands per milliliter. 1 milliliter of paint covers an area of 7 square centimeters. And we're asked to calculate the cost in Czar of painting the perfume bottle. Okay, and this is where we get to be problem solvers, so we're going to have to think a little bit here. We found out just a minute ago that the total area was 150.8. So I'm just going to make a note here. It seems like that might be useful down here. So surface area equals 150.8 square centimeters. And we need to be careful about the units here because it looks like there's going to be a unit conversion in here. They told us that 1 milliliter will cover an area of 7 square centimeters. Okay, what else did they tell us? They told us that 3 South African rands will cover 1 milliliter. So 3 Czar is also equal to 1 milliliter. So I'm kind of separating my facts here. Okay, so now we need to calculate the cost in Czar of painting the perfume bottle. Well, let's start with the surface area. The area was 150.8 square centimeters. And now we need to use a conversion factor. We want our end result to be in Czar, or South African rand. So what can we do? We're going to use the information right here to make a conversion factor. We have centimeters right here, so we need to divide by 7 centimeters. 7 centimeters squared is equivalent to 3, according to this calculation, 3 Czar, or South African rand. And so now we can cancel out the square centimeters. So now we just need to type this in a calculator. So 150.8 times 3 divide by 7. And we get 64.63 Czar. All right, what's going to happen next? Temi is going to sell her perfume bottles in a craft fair for 325 South African rand each. Dominique from France buys one and wants to know how much she has spent in euros. The exchange rate is 1 euro to 13.03 South African rands. Find the price in euros that Dominique paid for the perfume bottle. Okay, so let's check out what we know. We know that she's going to sell for 325 South African rands. Dominique is only going to buy one. Okay, that makes the math a little bit easier. Wants to know what she spent in euros. It's just an exchange rate question. Okay, so Czar on top, which means we need to cancel it out with Czar on bottom, 13.03. 1 euro on top. And I should have written ZAR down here. And guys, remember the reason we do top and bottom is now these units can cancel. So cancel, cancel. And so now we just get to type it in. 325 divided by 13.03. And she spent approximately It rounds pretty close to 25. Let's go 24.94 euros. All right, now let's do one final example before we end today. Okay, this one's going to be about a cylinder. A cylindrical container with a radius of 8 centimeters is placed on a flat surface. The container gets filled with water to a height of 12 centimeters, as we can see in the diagram, and they labeled that up for us and showed us where the water is. Then, a heavy ball with a radius of 2.9 centimeters is dropped into the container. As a result, the height of the water increases to 8 centimeters. Guys, if you're not sure what's going on here, it's the same thing. If you take a glass of water, you throw an ice cube or two in it, the water level comes up. If you throw in too many ice cubes, it'll overflow. That's exactly what's happening here. It's just that it's not ice, it's a ball, which makes it easier because the ball presumably is not melting. Okay, so the height of the water was 12 centimeters. Now it's higher. Makes me think of when you go to get coffee, you get an iced coffee and they fill the whole thing with water, and then you're like, wait, where's my coffee? Anyway, so we're going to find the volume of water in the container. All right, well, if the shape is a cylinder, we'll do part A up here. If the shape is a cylinder, then the water is taking the shape of a cylinder. It's just that the height is 12, not the full height. So the volume of a cylinder is pi r squared times height. Let's just plug in these values. So pi times 8 squared times 12. And I'm going to take a minute to type that in my calculator. And I get 2,412.7. And that is cubic centimeters, excuse me, because it's volume. That's part A. What about part B? Find the value of h. Okay, so h is what is the height now? Okay, and so we knew that this was the initial volume, right here. And then they just said that we added a ball with a radius of 2.9. And it's still centimeters, same unit. So what is the volume of the ball? So 4/3 pi r cubed. And then we would want to plug in the radius of the ball, so pi times 2.9 cubed. And the reason I'm doing this is, if I know how much water there is, this is how much water there is, I'm figuring out how much ball there is, and if I know that, then the total volume is just those two numbers added together, because that's what's in here. I have the water and I have the ball. So let's type that in. So 2.9, let's cube it. Let's multiply by pi. Let's multiply by 4. And let's divide by 3. You notice I kind of did that in reverse order. So I just got 102.16 cubic centimeters. Okay, and so what is the total volume? The total volume is those two numbers added together. So let me add 2412.7 to that. And I get 2,514.9. We're going to round that, 2,514.9 cubic centimeters. Now that doesn't answer the question yet, because they didn't ask for the total volume, they asked for the height. However, look in the second diagram. You see how the ball and the water together, because the ball sank, they've taken on the shape of a cylinder? And so I can use a cylinder formula right here for volume, because it's a volume. So pi r squared times the height. But wait a minute, we know what the radius is, because the container didn't get bigger or smaller, so let me erase r. Let's actually put 8 in there. We know what it is. So in goes 8. And now this is a solvable equation. We're going to divide by 64 pi on both sides. Divide by 64 pi to get rid of that 8 squared and the pi. Boink, boink. Okay, and then I'm going to divide my number from the previous calculation by 64 pi. And we get that the new height is only 12.5 centimeters. Now guys, think about that for a second. This is essentially the same thing as you dropping an ice cube in a glass. It goes up a little bit, not a lot. The initial height was 12. It went up half a centimeter when you dropped a ball in there. Okay, and so that kind of makes sense if we think about it. Folks, I hope this video was helpful. I hope you enjoyed it, and I'll see you next time.